1, 2, 3 test. 1, 2, 3. Okay, that should be good. Hello. My name's Brandon, aka Glump1. Someone had this idea that I start posting my one-liners. Let's see. Which one is it? There's going to be one-liners. Oh no, this was a contest. I post a lot of one-liners because I've done most of these problems already, like all the dailies. So, and it's surprisingly fun to do these one-liners. So, I am behind because this weekend I went out and so actually used a bunch of my tokens. But for most of these, I just blind submitted whatever I had. So I'm gonna go back through and make them into one-liners. Have some extra time because I gotta wait for my AirPods to charge. And then I'm gonna go to the gym. Okay, longest square streak in an array. So the idea is what subsequence what's the longest subsequence where you take the smallest number, you square it, you get the next number, you square that, you get the next number. So for here, you would want to take the 4, the 16, and the 2. And then you get 2 squared goes to 4, 4 squared goes to 16. If there was a 256, then the answer would be 4, I think. Yeah. So it looks like I already did this. I think I did this maybe last night or something. Yeah, I was watching X-Files and I did this. I'm not going to have these be very formal. I'm not trying to edit this together too much. In fact, I don't even think I'm going to have the cam most of the time because I'll probably mostly be doing these while I'm watching TV. But just to explain this one, so it looks like what I'm doing is I'm saying, okay, there's some sort of dictionary, D for dictionary, a lot of unreadable code. We got to get used to that. So, and then I'm creating this map object, which in Python is take some sort of sequence and then output some sort of function applied to every element in that sequence. So I'm saying take sorted set nums. We don't give a shit about multiple 4s. We don't give a shit about multiple 2s. If there's a 2, that's all we care about. If there was a bunch of 1s, we would care, but there can't be any 1s. And we want it sorted because you kind of want to check the 2 before the 4, in theory. Or at least that's what I'm doing here. And then it looks like I'm saying, okay, set the dictionary item. I'm saying take this, go to this squared, make that be 1 plus whatever this was. Or if there's nothing here, then make that be 1. So d.get is going to be try and look for an x in D. If there's no x, just return 0. And this is actually a great example of my coding style here, where it is not reflective of my coding style in waking life. What I'm doing here is I'm saying try and get a number from D, the dictionary. If you can't find it, get 0. That's exactly what a default dict int would do. It would say, okay, well, if it's not there, use the default constructor for an integer for that. And then I wouldn't need this d.get. I could just say d at x. And unless there's some other use case for it, this should just kind of work still. Yeah. So this is a lot more readable in a way. I think you could also just do this with counter, which would be slightly less characters than default dict int. But that's the thing, is that I'm going for shortest characters. That's something I care about here. So I think .get x, 0, and then you get to remove all these. Slightly shorter. I guess this brings me to since this is the first video of potentially multiple, I sort of have different priorities here. So I've got 1. Let me zoom out. That's too fat. It's got to be a one-liner. I'd say the second thing for me is no list comp. List comprehension is x plus 1 for x in array is going to give you every number plus 1 in Python, and it's really, really good to have under your belt. But if you specifically challenge yourself to not using list comp, it's often achievable, and achieving it often is makes you use the more interesting iter tools functions and stuff like that. 3 is usually maybe there's a 1.5 in here that I'll add in a second. 3 is probably no lambdas. Because again, it leads you to more interesting code if you do that. 4 is probably least space. And then I would say 0 is like best O of f of n, like best time complexity. And then maybe 1.5 is like simplest approach. If there's some really, really complicated way to do no list comp, like, you know, at some point it's just short. It's so much shorter to do this that I would rather. Yeah. And then I just check the maximum values. So kind of cool. So this is, I'm going over the time complexity n log n because we're sorting it. Or n log n, where n is the number of distinct elements rather than the number of elements, I guess. Max of that in n because we make it into a set. Yeah, someone brought up an O of n solution. Maybe I'll do that later. I don't want to do that right now. Let's see what else we got. All right, here we go. This is gonna be the first real one that we actually like do something. So, got to count all the 1 squares. So there's a 2x2, 3x3, a bunch of 1x1s, all that. That's my insane brute force code that should not pass, but it does for some reason. So what are you gonna do? But that's just because I like dropped the ball and I had to do the like redeem a token thing. So now I'm gonna actually do it. So if you're not doing, that would be O of n cubed, I'm guessing, because I think n here is like 300 and m, but I'll call them both n. That's probably O of n cubed. I probably have 3 nested loops. Yeah. Looks like there's maybe a little bit of optimization. I don't really know, but I'm not going to think about it that hard. So my first idea was, what about like a monotonic stack where you like measure the height? Because that's a way that you can reconcile like the areas of rectangles and stuff like that. That's kind of a bad idea. I think that's going to be really hard to implement into one line and really, really hard to implement at all. It's just going to be a bunch of bullshit histogram stuff where there's going to be like, if this is your current row, you're going to have all these like rectangles of potential ones that you can use. You're going to have like that and then that, and you got to be like, okay, well, like get all these ones, but then like, do you include these ones or would you include that when you do that? Like it's going to be a nightmare. So I think I'm going to do like narrow DP. I think just because I happen to see someone do that. So what it's probably going to look like is I'm going to say, what are all the squares you can draw originating from this at the bottom right? What are all the squares you can draw originating from this at the bottom right, this at the bottom right, this at the bottom right, this at the bottom right? And then when you get here, you're going to say, well, it's kind of going to be all the squares you could draw from here or all the squares you could draw from here, potentially +1. Right? It's going to be something like that. Or really, I don't even think you would look at these. I think you would just look at this and you would be like, no, you have to look at these too. Yeah, it would kind of just be the minimum of these. Something like that. I'd have to think about that a little bit, but yeah. So I'm just gonna get down. If it's like an easier problem, like if I choose probably a random one of these, this was probably easy enough. I remember this one. This was easy enough that like I just do it in one line right off the bat. But this is like complicated enough that I'm gonna do it in multiple lines and then get it down to one line. And that's probably what I'll do with. I remember the other one on like Friday was pretty difficult, or not. It was just like involved. So I'll just get this down to one line potentially, or I won't. But I don't think there was too much going on there. So I don't. First off, I think I can do this in O of 1 extra space. I can just use the matrix itself as like the DP array. So I'll probably say for I in range n, m. For j in range n. And then something. So I'll be super explicit to start. If not, And I'm going to just change matrix to be A, because I know I'm going to do that in the end, and if I don't do that now, it's going to be annoying. If not A at I at J, continue, just don't do anything. There's going to be res equals 0. Okay. So you're looking at what matrix at I at J is going to represent is going to be, I'll say the largest square that can be made going up and to the left. So at the end of whatever's going on, you're going to say res plus equals A at I at J. And then I'm going to modify A at I at J to be the right thing. So I'll look here. I mean, one way to think about it is like just A at I minus 1, J minus 1. But I guess it'll be the minimum of these 3, right? Like if each of these was 2, or let's go here. Like if each of these was 2, then that means that like there or there would have been a 0. And then the answer here would be 2. No. Oh, no, then the answer here would be 3. So it's the minimum of all those plus 1. I kind of want to have a buffer so that I don't have to always be checking like if J. Because like that's fine, but if I'm taking an aggregate minimum, it's going to be really annoying to be like MSF is going to be infinity, and then if I take the minimum of that, or something weird. Or what it would really be is like if I else MSF is 1. I would rather just like do multiple loops. Well, and here's where we're getting into the line consolidation. So I could say for I in range M, res plus equals matrix at I at 0. Or I could just say sum map item getter 0 A. I gotta change these to A too. So now I'm saying look at everything in A, look at every element, every row, map this to it, this being get the 0th element, and then add that. So it's going to add the 0, the 1, and then a 0. So that handles the columns, and the row is really simple, right? The initial row, it's just sum A at 0 to make sure that A exists. Yeah, it does exist. So that handles all of these, and now I can say 1 and M, 1 and N, and now I can safely use I minus 1, J minus 1, and so on. So is it just as simple as the minimum of these 2 plus 1? I kind of just, in the spirit of janky code, I kind of just want to test that and see if it works and like go from there. Equals min A at I minus 1 at J, A at I at J minus 1, plus 1. And then I also, if one of these is a 0, then it's just fine. Then that'll be 0 and this will be 1. If both of these are 1, then this actually should also be 1, right? Because like this, so maybe you do just literally need that. A at I minus 1, J minus 1. Because that I'm a lot more confident in. You always want to just look at this, and as long as these match up with that, you're good. Like as long as these are at least the amount that this upper left kitty cornered square is, then you're kind of good. So I think it's going to be something like this. 8. What do we got? So in the first row, it picks up on 6. And then it gets 8, which doesn't seem right to me. No. That's because I'm like counting for these already. So there's 5 elements. Oh, well, one thing that's going on immediately is that I'm double counting the 0th. So I just want to say the first row plus the first column minus A at 0 at 0. All right, well, that doesn't bode great But if all these pass, I don't really want to make some big test case. I'm not like getting time penalties for wrong submissions. So there we go. All right, so let's get this onto one line. It actually should be really simple. I mean, like I know I can do it in one line. I can't imagine you can beat this time complexity, so that's good. This is a pretty simple approach, way simpler than the deck. It's also O of one space, which is cool. It's actually not O of one space. The map is O of one space because you're iterating through this map of item getter 0 and A. So that's fine. Sum of A0, that's fine. No, it is O of one space. Works out. Cool. So I think I'm ready to just start like doing this. So I want to say something that's like, the first thing that's kind of tough is like, I want to keep track of this res variable that I'm changing. This is like a mutable variable. So one thing I can do is say res equals 0, but then the problem is if the very next thing I do, this would need to be an or what I can do to be really cheeky is that. And then this is saying it's a tuple that contains the fact that res is 0, which then this will register as a container of something. So then I get to use and because this will register as true if cast to a Boolean. But this would register to false because it would say, okay, well, you said res was 0, and then this expression is res, which is 0, and that evaluates to false. So that's fine. Anyway, if I said something that was like res plus equals 1 for, or let's not even say that. Let's say res colon equals res plus 1 for x in range 100 and res. Oh, well, that works. But I find in general, it's like you don't, no, this is like a bad, no, okay, I know what's going on. If I said something that was like, right, what's rule number 2? No list comp. So let's get rid of list comp. Here, it's okay with this. This is somewhat readable. But if you said, instead of this, we wanted to get rid of the list comp, we would say, right, we're just doing the same thing for every element. So it's going to be map lambda whatever, because we don't even give a shit about what x is. Res colon equals res plus 1 range 100. So this should still print out 100, but I don't think it will. It'll say invalid syntax, and what's going on is it's saying, well, first things first, let's just say list. The problem I think that it has is that you're trying to set res to be a new variable inside of this map function. So you're using this anonymous function to do this, but it really doesn't like that. So what you would want to do, and maybe there's some other issue here, but you would say something that's like res equals, that's a 0, and then here you would say res.append res.pop plus 1. And then it'll work. And then you just say like res.pop. So this is the way to get around like using an immutable variable as mutable, right? Like integers are kind of immutable, they're immutable, and so you just are like, all right, well then wrap it in something mutable. Pretty lazy. But we don't even have to do that. We can just have this be a sum of a bunch of stuff. So we're not even going to define res, probably. We're probably just going to say, right off the bat, all right, what are all the sides in the first corner? Okay, so that's done. Plus this whole expression. So this expression is going to look something like blank for j in range 1 to n for I in range 1 to m. So if we change this into a map, it's going to look something like map something, right? And this is going to be the j variables, this is going to be the I variables. The other thing I'll point out is right here, let's go back a little further. I say list map. The reason for that, it's the same reason that this is O of one space. It's because this is going like element by element, but we're not actually unpacking that into anything. And earlier I had this immediate impulse to say this is going to be O of n space. This will be O of n space because we're unpacking the map just to like have it parse all of these, have it like change res appropriately. So this would be O of n space. So if we go back forward, here we're going to have like map something to range 1 to n, something to range 1 to m. So now it's like lambda I, map something, lambda j. And this is where you get into whatever. If I can't do no lambdas, there's no way to do function composition to my knowledge in Python without using a lambda variable. It's really hard to do that. So when it gets to function composition, I just use lambdas, and that's fine. So now we have access to an I and a j. But if we think about it, if we just cast this to a list right here, this would be O of n, because it would fill up this list with this map object. And we would actually have a problem. It would fill it up with these unused map objects, so each of these would need to be a list too. And then we would have a list of lists. It would just be O of n squared. It would be m by n. But the way we're going to get around that is we're not going to say list. We're just going to say sum. And then this should be O of 1 again, because it'll just go element by element. Okay, lambda I, lambda j. So right here is going to be the meat of what we care about. How do we get this? Well, we're doing two things. We already know. First things first, I'm immediately going to say a at I at j and whatever. So now, if a at I at j is 0, it's immediately just going to return nothing, and that's what we want. And it's not going to do anything after this point. And now we get to say, okay, well, a at I at j is something, so potentially return that, but make sure the element after the expression after this is also something. And it's a little bit mind-bendy, but instead of like eventually we're just going to say and something ... and a at I at j. And then whatever we did here is going to change a at I at j to be the right thing. It's going to be this logic. And then we're going to say blah, 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 blah. And okay, in the end, now this is going to be this. The problem is, what is this, right? We can't just say a at I at j equals min. We can't even just say a at I at j colon equals, because it'll be like, what the hell are you trying to do? Like, that's not... that's just like not a valid expression in Python. So instead what we're going to do is we're going to say, instead of a at I at j equals that, it's going to be a at I dot set item j and this whole thing. I didn't type the j and that. Looks pretty good. And it'll give a really fucked up answer because this is all there, but... All right, now we're getting into the good stuff. So it's saying unsupported operand for int and none type. I know exactly why. It's because we're saying, all right, get the first rows and everything. That's great. But here we're saying, make sure a at I at j is something. Great. And do this. But this is a void function, so it returns none. So we really want this to be or, because that'll always return none. And look at that. Last thing we have to do is decide, do I care about m and n being declared? Do I want to say m colon equals this, n colon equals that? No, because I use them once. So I'd rather just say length of a at 0. There we go. All right, what else we got? This one's pretty difficult, but I already did the code, so it shouldn't be that bad. Or maybe it will be, I don't know. So my thought process with this one, I don't know if there's multiple ways. I think maybe I did this on a contest a while back, but I didn't remember it. So what I did here was just said, do 2 DFSs. The observation that seems really important is that any subtree won't matter. If you delete the 6, it won't matter. If you delete the 2 and the 3, it won't matter, except on the longest path. And if there's multiple longest paths, like to this 4 or to this 6, both of those are valid paths, then neither of them matter. So here, no matter what you delete, you only deleting the 2, the 8, or I guess the 5, although you can't, will actually yield any difference. Deleting any other number won't change anything. So it's just a matter of like, what's the longest path from whatever node to a leaf node. So like 5, the answer would be 4, or 8, the answer would be 3, or 2, because they have the paths in terms of the number of edges. So that's what DFS1 kind of does, is it's just like fills up this height box. And it also finds, it's like kind of inconvenient here to find the number of nodes that there even are. But because the nodes are numbered in the natural sequence, we can just be like, what's the biggest number we come across? And then that's going to be our height and our res array. Yeah, so we fill it up with the biggest height, the biggest distance from this node to a leaf node, sorry. And then DFS2, very aptly named, is saying what happens if you delete this. If nothing happens when you delete this, say you're at 3, then you're done. Then you don't have to do anything. Actually, you would never even reach that. You look at both children and you say, what would happen if you deleted one of these? So if you deleted the 3, nothing changes. So don't even go into that. Don't even do DFS2 into 3. Only do DFS2 into the one that matters. And immediately the fact that we're only, I'll just say DFS from now on, we're only DFSing into one of the 2 nodes, like child nodes of a given node, means that we know we're going to trace a path directly down to the longest path, to the extent that it's even a distinct path. Yeah. So an important thing to recognize is if you delete a node and it doesn't do anything to the maximum height, then the answer is just the maximum height. So I fill up like the default of res to just be the maximum height for every node. And then if it's different, then you change it. So then you trace along this longest path. You say, look through here. I forget what the deal with the -1 is. Is there ever a world where I care about that? Why is this -1? Could this just be anything? I think it's not. I think that will like fuck it up, but. Uh-oh. No, well, I probably have to change both of them. Yeah, this fucks it up. What is this? Case 3. 1 null. Let's go to this. 1 null 5. And then I'm trying to delete node 3. If I delete node 3. Well, I don't know why this is supposed to be -1, but I'm not going to think about it that hard. Last night me is correct. So if they're both the same, then you no longer have any distinct longest path and you're done. Like for example, you get to this 4 and the 6, it doesn't matter what you do at that point. If the longest path is to the left, go that way. So DFS through. You don't even change anything in the right path in this situation because it's not the longest path, so deleting it doesn't do anything. But you do want to check, like, if I deleted something in the left path, would the right path be the longest one? Like if I deleted here, for example, the 8 and the 9, if I deleted the 8, the 9 is going to be the longest path. Or when we're at the 8, if I delete the 2, 5, 8, 1 is going to be the longest path. Or say 3 had a child, then when you delete this 2, this, might not be the longest path anymore. It'll be like something way over here. So we do want to keep track of MSF, which is going to be a lot, but I think it'll be okay. No, it'll be fine because we know we're going to use lambdas. Like this is a recursive function. I could change this into a stack representation, but that's such a nightmare. It wouldn't be that bad, but it's bad enough that I don't want to do it. So we'll just use lambdas. Yeah. And then in the end, I just say, the way I've organized res is if you deleted this node, but we want it in terms of the queries. So I just say, okay, we'll map each element in the query that's going to correspond to that value in the res array. So just like look at that array instead of just like, yeah. And then return that. So let's get started here. Well, yeah, I'll just say res : equals that, height colon equals that, and I'm just going to have all these in like a tuple. Okay, and then we want to say I'll say F1 for the sake of not that many characters. Colon equals something. And then call that on root. Looks good. Okay, and then what's this actually doing? Oh my god, this is going to be annoying. So a while loop kind of corresponds to a take while object, and similar to a map object unpacking into a list, we kind of want to say list take while. That's not the greatest space complexity, but it's fine. I don't even know that I need the list. Something you can do too is like, here I'm building a tuple that's just like declare this, so that I don't have to say and or over again. I might want to do something similar here where I'm just like return a big tuple that's all the things I need you to do. That's probably what I'm going to wind up doing. Yeah. So, and then that allows me to not have to say list take while. Now that it's in an object, I can just say take while something. Lambda something. And then I'm going to say int 1e9. So just do this forever. Range int 1e9, excuse me. So do this forever. The thing I want you to do is length of height is less than or equal to u.val, and so the take while will end when this evaluates to false, and height dot append none, comma. So now we're doing the cheeky little tuple thing. That looks pretty good. Okay, what's this doing? This is the map of the DFS. And I think I'm going to end it there for now and just say and height. And it should, I just want to check that it's like, well, sorry, answers. You're going to be wrong for a second. Okay, it's because this is lambda blank. I want this to be lambda u now. Okay. This is right. The value is 1. So if we go to something else like 5, yeah, okay, this is doing what I want it to do. Now I just need it to DFS through other things too. So I say F1 is this, and now, okay, cool. So you've added the correct elements in. Now I want to say do a bunch of shit and then return H. So I'm saying if any of the children aren't none, whichever child isn't none, DFS1 through that. So I could map this, right? I could say H is the maximum of these. Yeah. And I actually want to use the non-one-liner code to make sure that this is the case. So I'll turn this into a one-liner like in its spot. I'll say H equals maximum of these. Okay. Plus 1. And then I want this to be the maximum of mapping DFS1 to those. Okay, and then I want to say if you didn't, if the map is empty, then I want it. That's going to be a problem. I think it might say you're mapping an empty sequence. I'm going to do is copy this. I'm going to get this back. Okay, this works. So if I just say like list map, partial, no, that's way too complicated. Lambda blank none to res. It's not going to freak out, right? It's like, I know that yeah. So I can map to an empty thing. I don't know why I forgot that. So it should be fine. It says map that, but the thing is I can't take a maximum of an empty thing. So, and what I'm really don't want to do is say default equals -1. That's like, this would be this same code, but the default is like annoying, but whatever, I'll keep it. What I want to do is say like plus -1. That's like a little shorter, but the problem is you can't like add a list object to a map object. Okay, that's fine. I think, so I can say h : equals that. And I can do this because I'm declaring h in the local scope of this f1 lambda function. Max, blah, 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 +1. Okay, now we have h. And we're just returning it, right? Oh, and we're setting the value to be that. Is there a way I can do this without using 3 terms? Because I could say set item this and h or something like that. That's fine. But I think I can consolidate these. I can say height dot set item to be that, and then this will declare h in the set item. And then I can say and h. And this will always go through because this is like a big tuple. Oops. So it's saying do all this shit, h will have been defined, and then return h. And then you use that for other stuff. Okay, so now this should return the correct heights for everything. DFS1, F1. Expected 2 arguments got 1, so this is where we got to start splitting it into multiple lines. Probably what's going on. Okay, this map is correct. This is fine. This max is probably fine. Set item. Oh, I think it's that I'm not actually saying like what to set to be h. We just want u.val or something like that. Yeah, h height at u.val. Okay, so who gives a shit about node 0? Because there's no node 0. So it's saying a height of 3, a height of 0, a height of 1. This seems correct. But I'm going to make sure that this like matches with... Yeah, so it's the same, so it's fine. Okay. Okay, so height is built. That takes care of that one. And now we got to do F2. And define res. I don't know why I define it to be empty here and then define it. I think it's because originally I had like res.append none there. But this is just easier. Okay, DFS2. So F2 is going to be something, and then we're going to take F2 and we're going to call it on root 10. That's just what we're doing, because it looks like that's the height we're at and the MSF. So great. Now when it comes to L and R, I don't really want to like write all of this out just on one line as opposed to multiple. There's probably a way to consolidate this nicely. So that's like the next thing I got to think about. If it comes down to it, I know it's going to be fine to just like do this all in one line and say L : equals this, R : equals that, and do like the ternary operation. But is there a nice way Earlier when I was like, can I have these be 0? That's because that would make it a lot easier than doing this whole ternary operation. That's like not the shortest code ever. So immediately I could say LR equals map height.getItem to that or something. Or yeah, that could work. That could work. I think that's okay. I'll say that. So LR is going to be lambda. Right, well, right off the bat, it's going to take U, H, and MSF. How much do I use height? I feel like I use height a lot, so I kind of want to rename that to H, and then just like whenever I use H, rename that to something else, but I'll deal with that later. It's going to be all this. First thing I do is I say LR colon equals this. And if LR at 0 doesn't equal LR at 1, and yeah, and then I could have like a convenient maximum where I just like do the same thing. That's not too bad. Where I can consolidate both of these into one line. If I like zip L with U dot left and R with U dot right, and then I call it on the maximum of those two. I have to be a little clever about like referencing R when I'm talking about L, but it should be fine. Yeah, R would just become minimum of LR, so that's okay. Okay, this doesn't actually return anything. So F2 is just going to be a big tuple. I'm just going to like list all these things. So right off the bat, LR colon equals probably list map something. You get really good at telling parentheses. Okay. And I think I'm actually not going to have this in a big tuple because now I can just say and LR at 0 doesn't equal LR at 1. And so now it's like stop here if these are both the same. That's going to like save me some headache. And then it's going to be do something to the maximum of the zip here of L and U dot left and R and U dot right. So how do I say that nicely? Because I'm not mapping anything. I'm not mapping to an iterable. I'm just using one variable for something. Well, okay. Here's a clever thing I can do. I'm never referencing L in this code block, and I'm never referencing R in this code block. So all I need is U dot left and U dot right. So I can say map item getter 1 to the maximum of the zip of L U dot left R U dot right, and then it'll get me the bigger corresponding child node. Yeah. That's like, maybe there's a better way to do that. But if there is, it'll come to me while I'm typing this out. Okay, so now we're going to do a tuple because I don't really care what these return. I just want to like do them all. I'll say the child node is going to be max of something at 1. Again, I don't have to like map anything. It's going to be max of zip U dot left and U dot right and L and LR. Okay. I still have to make LR, but I'll do that in a minute. I don't think it's very smart to set. Earlier, I was outlining in a lambda function, you don't really want to like be setting variables outside of its scope. I think it's fine to do that with MSF. If right here I said MSF colon equals something, it should kind of understand. Because that's like an input variable, and like if I wanted to right here, I could just say like queries equals none, or if there was like I int, I should be able to be like I equals 0. It won't like freak out. Or I equals max of I and something else. So MSF equals max MSF H plus min of LR. Because now that's going to be L when R is bigger and R when L is bigger. And now I want to use this child variable to be correct. So it's going to be res.setItem something. And then the last thing is the DFS. So F2 of the child node H plus 1 MSF. Okay, and then this is going to be c.val is what we're setting, and we're going to set it to MSF. Looks good. Okay. I think, so I got to give this a once over, but I think all that I really have to do now is just set LR, which is not that bad. But again, it's like, this is so tantalizing because it almost feels like this could be really elegant, but it's not. At least the way that I have it in my head. So it's map height.getItem. I think I have to use another lambda, which is like really stupid, but that's fine. At least I don't have to have the ternary operator, I don't think. So right here I say map something to, I'll just say u dot left, u dot right. I don't think I'm gonna beat that brevity. Lambda C. So what's this child node doing? And again, this is like in a different scope than this C, so it's fine. And I'm just using C for like child node. Like both of these are kind of referring to the same thing, so I think it's okay. Lambda C. I think the way I'm going to say this is C and something or -1. So now I can say like if C exists, then do this other thing, or just return -1. Height at C.val. That's not too bad. It uses a lambda, which isn't great, but I don't think it's too bad. Maybe it'll just work. Cannot use assignment expression with lambda. So somewhere around here, one of these colon equals is, it might be this MSF colon equals right here. If it is, I'm going to be sad. It's not. So it's probably something that I can remedy. No, that's okay. Well, no, this is kind of sketchy, actually. It might be this. Right here, I say LR colon equals something. Wherever that is, right here, LR colon equals list blah, blah, blah. And I think this was when I was translating this from a big tuple to a series of ands. I think I forgot to delete that comma. And now that this is separate, I need this in like parenthesized. It can't just be free, or else the interpreter won't know when colon equals ends. Like it won't know if I mean like map all that and this as like the part of LR, or if it'll be like LR has ended. Okay, all right. Oh, okay. Now we just get this. I already kind of got this on one line. Maybe it'll just work. Okay, it does not just work. Oh, man. Well, this is tough, because this is going to be some very slight little thing. So what could be happening here? Right off the bat, I think something that might help is I'm getting rid of node 15. So can I just find node 15 here? Okay, I cannot. Let me look. Let me DFS this. No. Okay. Interesting. So node 15 is like not there. If I'm not mistaken, the number I was returning was too small. So I'm thinking that node 15 is doing more than it is. This seems very much like either my playing around with LR has landed me in some hot water, and I'm referencing R when I want to reference L, something like that, or there's just a straight up typo somewhere. Like it's either a problem, my guess would be it's either a problem with that logic, or it's like I literally pressed the wrong key and it's like a matter of dexterity. So let's see, the answer's 10 when it needs to be 11. We know that it's going to be along the longest path, which is like 13 or something. What is it? 12. Let's say it's this. So, which it probably is, because it looks, the way that this test case looks, it looks like it's going to be one of these two. And then it's a height of 2 larger than its sibling, or than the other maximum thing. Okay. I think something I'm going to do to check real quick before I get super into the debugging is just print something. I'm going to say length of height is greater than 15 and print height at 15. So just like what even am I saying that the height is? The height is 1. So that tells me that height is literally the leaf node of the whole tree. No, it doesn't. Yeah, it does say that. It says it's the parent of the leaf node. So height here would be like 2. It would be like what 2 is in this tree. Which is interesting. That gives me a lot of information, actually. It's good that I did that. Height at 15 is 1. Right, because like height at 2 is 1. And so on. Just to double check that. Oh no, here it says height at 2 is 0. Oh, but that's a different example. Okay, yeah. Which checks out, because 15, 17, null, null, 14. So probably what's going on is there's 15 probably then has a sibling child. It's not... Let me think about this. 15 and then 17. No, not necessarily. If these are both next to each other, these are both either siblings or they are like 1 and 3. They're like in order successors of one another. Right? Because like let's say everything else was null, you'd say 5, 8, null, 1, 3, null. So they're not necessarily siblings. But I'm gonna say maybe they are, and that's where the problem is coming from. I'm gonna keep that in mind. Height of 15, height of 14, okay. So I'm going to start separating this out into multiple lines. Let's say I generally just separate on commas. It's really rough, but For me, I've gotten to a point where I'm like, I know it's a little messy. I don't really care. Like right here, it's such a weird spot to return, but it's just for me, I know like after a comma, I can always put a new line and it's not going to freak out. Just makes it slightly more readable. So what I want to do is say when u is 15, like print something or look at something. List map that. Okay. That's fine. LR at 0 does not equal LR at 1. Should be fine. Okay, now look at the maximum child. MSF is the max of that. I actually kind of want to look at when one of the children is 15, not when this is at when u is 15. I don't really care when u is 15 because its answer has already been set. So I'm going to say C equals max of all this. C equals C dot val equals 15. And print u dot val. You know what I could do? I could print u rather than u dot val, and that will tell me. So this is node 16. It's saying left is 15 and right is 17. So I know now they're siblings. Okay. Print this. I think I'm going to copy that, and I'm going to move it around. So I'm going to say MSF is that, H plus the minimum of LR, which should be 0. It should be 17. U, LR, MSF. So LR is 1 and -1. It's saying 15 has 1 child, 17 doesn't exist is what this is saying. So I think that's probably where the problem is. I think it's right here. The way I've set this up is not right. Yeah, the way I've set this up isn't right. It almost works, but height and c.val could return 0. So I really want that to be this always evaluates to 1. Fuck. Well, now lambda c, do that, or -1. Well, now it's going to return the tuple. So I guess at 1 is fine. That's like weird. Okay, this shouldn't be that hard. So if C doesn't exist, immediately return -1. Or I don't think this is ever going to work if I have this or -1 here. I think my logic was like not right because c.val could be 0. So do I really just want to turn this into a ternary operator? I don't love that, but I mean, this is obviously really close, but no ternaries for me is probably around no lambdas. Like if I can avoid it, I kind of want to. And you almost always can with these like and or. But there's no possible way that I'm going to have or -1. So I think what I want to do is swap these. I want to say C equals none and -1 or this. That's the way to do it. So now I'm saying if C is none, you're always going to return -1. And if it's not none, then it's going to be this. That was a hairy one. I'm glad I got that so quickly. Let's get these out of there. Oh my How many print statements do I have? 2. So I got to get rid of that. Should be good. And then this one should be pretty simple. Let's just get rid of this. Whoops. This goes to here. Okay. Oh, I think I just forgot about this too. Pretty slow, but it gets the job done. I wonder why that's so slow. I wonder if I say or that or print C. For case 4, it should only be doing that like, well, I'll say C.val 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Interesting. 21 times. Why would it ever do that more than 12 times? That actually tells me there's something wrong with this. Let's see, all this. Now I don't really want that other print. Well, no, I kind of do want the other print. So oh no, you know what? This is kind of whack. I'm doing some sort of weird post order. I don't want this here. I'll just put this like immediately here. So the moment GFS2 is called on anything, I'm getting this info. We should see, what's the root? The root is 8. It leads to either 6 or 37. Okay, this is right. Oh, no, it's fine. It's fine. It's fine. It's the reason why this is 21 is because actually the longest path is potentially less than 12. And here where I'm printing C, this is like the candidate for both children. So it's fine that that's the case. That means like I'm reading both children for every node on this path, which is good enough for me. That tells me that this is indeed the correct time complexity. There's just some sort of like problem with, I don't know. It's kind of worth surmising. Let's see, list map res, that's fine. Res set item. It might be all the max functions. I learned from someone that's like way better. They don't even use Python, but they're better at Python than I am. And they said like, because Python evaluates overloads at runtime and max is a function that has a lot of overloads, you're way better off just like custom doing MSF equals negative infinity for X in the array. MSF is max of X in the array. You're better off doing that because there's so many overloads for the max function. That's maybe my guess. I don't know. Let's clean it up a little bit. Oh, look at that beauty. Sweet. I'm all caught up. I think I am. Yeah. I'll edit this down and get it uploaded. Thanks for watching.